So this is a Parallax Cyberbot line follower. It will follow this map. It has lots of curves in it. I wanted to give it a challenge. And it is using an IR sensor IR sensor unit right here. Okay. This IR sensor has both an analog output and a digital output. The analog output is used. It goes into P2 of the microbit, and it gets 3.3 volts and ground from the Parallax Cyberboard. Okay, we're going to watch it run. This is out of the box. I'll turn it on. First thing you'll notice is that it's showing a reading from the IR sensor. You see the lights, and it goes up anywhere from, let's see what we got here. Okay, it's a low reading here. So this is high reflectivity. And then when it goes down over the black line, you'll see it goes up considerably higher, and it's measuring the amount of light reflected back. And it is started by tilting it forward. I've reserved the switches for other uses, so I'm going to tilt it down, beep, 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 and it will start following the line after 3 beeps. Okay. At the moment, it is traveling at a relative speed of 30, and the way it works is it measures the light being reflected back. It's trying to follow the line, the black-white interface of the line. See if it comes down. This is a relatively easy curve for it to take. Okay. It's using a PID algorithm. We're only using the proportional term, which is enough to get this to go around. And what I'm going to do when it gets back to where it started, I'm going to put it on the other side because it's a challenge, whether it's on the inside loop or the outside loop. This works either way. It's supposed to. Okay. You'll see that the IR sensor is pretty high up off the map. I tried to mount it down lower. I ran into some problems with it. Moving it up this high was just the next easy mounting point to put it onto the Cyberbot. See if it makes it all around these curves. These inside curves are the hardest, but seems to handle it well enough. If it crosses the black line, there is no recovery. Okay. To stop it, I'm going to tilt it up. That's a signal to stop it. And what it has done in the process, it will show you at the very end. I missed it there, but at the end it'll show you how many cycles per second it's been able to pass. So it's at 24 loops per second. So every second it's checking the light intensity 24 times a second and making adjustments. So it's working out to be pretty accurate. If you operate this thing in a basement like I am, and these are LED fluorescent lights, it works fine. If you try to operate this thing in bright sunlight, light coming in the window, this is an IR sensor, and it simply messes the readings up. To fix that, I've designed this little shell right here, which can mount on top of the sensor. And these are in a link that I'm going to provide for Tinkercad, so you can print this shell to go there. These are number 440 screws or metric 3 screws by 6 millimeters long. And the bracket that holds this on, this little red bracket right here, again, is held on with number 440 screws or M3 6 screws and nuts to the frame. And again, the design of this, I'm providing a link to it in this video description. And I was right pleased with this. There's a lot of tuning parameters in this thing, and maybe I should just keep talking. So right now, it ran right out of the box. But if you're not happy with how it's running, you can go access the tuning parameters. The very first one is the speed. Right now, I'm running it at 30. I see that go by. The next parameter you can check is the set point. This is what's used in the calculation. It takes the amount of light coming back, and it uses this as an offset. I've got it set by default to -20, and I found that simply by experimenting with it. The next parameter you can tune is the proportional value. By default, it's set to 1. for a speed of 30, which is the default speed, that'll work fine. If you increase the speed, I've had it run as fast as 60. That proportional constant needs to be up in the vicinity of 1.7. Every push of the button, okay, will increase it by 1/10. There's a table that determines how much of a jump it is. I'm going to push it again. So now we got 1.2, 1.3. Okay, I'm increasing the proportional percentage. The next parameter, okay, and I've locked out the derivative and the integral values because I'm not using them. So we're back to speed. And there you have it. The program is also available for download, and I wish you all good luck.